Okay, good afternoon, everyone. So, okay, let's start. So actually, this time we have small room, but actually, I hope more people will come. Yeah. Okay, let's start from the loadware. So we can see that the text of the loadware this time is a slight different from the previous one. The major changes is about the IPR things, which is defined in FC 8179. Actually, yesterday there were lots of discussion on the IPR topics, and so I think if people join the discussion, we can get more, information from that discussion. And so, if you didn't join the discussion anyway, we hope you can review this RFC to get better understanding on IPR issues. Yeah. So as usual, we have the audio recording. So please speak in front of the mic, and also state your name, before speaking. And also, please stand inside of the pink box. Yeah. So for the minute takers, and we ask Hao Mian. So I think Hao Mian and Oscar, they will help us to take some minutes. And also, if anyone can take some minutes through the Etherpad, that will be appreciated. Thank you. Yeah. So for the Jambo, we also will monitor the Jambo room to see if there are some comments from the Jambo room. So this meeting, we have two sessions. One is, joint session about young models, which has been done, And the second one is the right one, which is Ccamp specific. You can get some, material information from the link. So this time, actually, for this session, we have 2-hour sessions. So even though we have 2 hours, actually, you can see the agenda is still a little bit busy. So we really hope that the presenters could use the time slots efficiently and leave more time for discussion. Yeah. As we always encourage people to use the mailing list as much as possible. And we can discuss anything, technical things on the list. For example, we can discuss any open issues, introduce any ideas, and also we could use the main list to build up the working group consensus.
Let's proceed with the status of the working group. We don't have any new RFC since the meeting in Chicago, but we have a new draft in the editor queue, which is the FlexiGrid OSPF. We decided to put it on hold and to, let me say, define new values against the GMPLS SCSI, which is now which passed the last call and was approved for publication, if I correctly remember. And so we decided to use it as the basis for the OSPF extensions for FlexiGrid. What else? We have a lot of working group document discussed today. The first of which is the DWDM interface management and control framework. We just wanted to make you notice that we asked for an early review of the document. It was we asked for a review from the routing directorate just to be sure that it reaches a good quality before the last call. There are 4 more drafts in that are working group documents that will not be discussed today. First one is again the OSPF extensions for FlexiGrid. Second one is LMP extensions for FlexiGrid property negotiation. This is expired. I had a chat with Shilei. He said that he will discuss with the authors whether to move it on or drop it. The next one is extensions to OSPF for availability. This is another one that was waiting on the GMPLS SCSI draft. So we will now be able to move it along. And this one will be followed by the RSVPT extensions. Liaisons. We have a lot of liaisons. We sent one to the ITUT study group 15 back in May regarding Flexi and asking for what their intention was regarding the Flexi work. We received a reply earlier in July. It was posted on the list. And we received another liaison from the ITUT on an update on their work on the OTN work plan, and one from the Broadband Forum, again regarding Flex Ethernet and their intention on working on that topic. So this is it for the administrivia. We can start with the first presentation.
So my name is Rüdiger Kunze, and this is the management and control plane framework for DWDM interfaces. We presented this draft many times, and therefore I only go over the updates. Just roughly, so the main motivation for us is to achieve interoperability for optical interfaces that are outside the classic DWDM network. And the way to achieve this is using a common model managing and controlling this kind of interfaces. Let's go to the modifications we did since Chicago. So we have a new co-author added. So Julian from Orange joined the document and gave a lot of good comments and supported quite well. The new version was submitted in July, so 2 weeks ago. Document was updated twice since March. We addressed all the comments from the list, did a lot of rephrasing again and error correction. And we hope that we approve the readability of the document. So let's have a short look on the details. So I updated the introduction section. So we rewritten that. We did this completely new. Then we updated all the figures, explaining the text and harmonizing the text and the figures a little bit more. We updated as well the control plane consideration section of the document and the use case section, especially the first use case service setup. And then last but not least, we updated the requirements section of the document as well. That's what we did. One thing is still open. We have to update the reference section. So I run the NITS thing on the tool page. There were some minor things regarding the references. So we have to do here a little bit more work, and yeah, then we think the document is ready for working group last call.
Any question?
Hello, my name is Jan Koenraad. I'm from SysNet. I'm a newcomer. This is my first IETF ever. So first of all, really thanks for this document because it's, for me, it was quite nicely readable and so on. I've got one comment, it's something more on the editorial point. I noticed that the text refers to a yellow triangle when it comes to diagrams and measuring points. So just maybe remove the word yellow too. Yeah.
Okay, thanks.
Thanks. I would like to thank you for the various drops that really helps distributing the work between one IETF and the other and not doing everything in the last week before the meeting. And I think the readability is much better now. And I would like to see if there is enough support to move the draft to last call after the changes you still have to do. So let's put it the other way around. Does anyone object moving the draft towards the last call? No one.
Yeah, that's great. Actually, I think this version of this draft is pretty good. Just one minor comment. Please check if you use APC 2119 language. If you don't use this kind of language, please remove section 1.1, right? And then maybe we can move forward after last call. Yeah.
Good point. Okay. If there is no other question, we move to the next presentation. Thank you. We welcome back Giovanni.
Thank you. So Giovanni Martinelli presenting you the update on the WSON with impairment validation information model. As Daniele said, the draft was a bit dormant, and I mean, I was off for the last year from the IETF, but okay, now we try to, let's say, finalize this work that is around since a while. Not on the my co-editor, since he's no longer active in IETF, Waimo will take his place. How do we move? Okay, this slide just to remind where we are with this draft. So, I mean, the draft itself extends the WSON information model, the one without impairment validation, so the one that is already RFC 6446, and provide the definition for the new information required. The other useful information, just a reminder, that is independent of, from control plane options. At the time when all this work started, PCE was on hype, so everyone was looking at PCE as a final solution. Now there are more, let's say, preference towards solution like that goes SDN or based on Yang. The change in the draft was mainly editorial, so there was several typos fixed, and the other idea was to remove the references to the encoding draft that I'm going to present just after this one. But basically, the encoding shall reference the info model. I would try to avoid the reverse direction. So a reminder of the context on the content of the draft. There are two sections that basically provide the definitions and some introductory test. Section 3 was the one that was discussed with ITUT and include all the content from ITUT. Then the remaining sections relates more to IETF and control plane. So from author standpoints, we likely need to have to go through another, let's say, revision, but since with some cleanup, we'll appreciate the working group having, let's say, careful reading, and then I guess we are ready to go for a last call. So if there are any questions here, I will take question, then I will move to the other draft.
Thank you, Dieter, for making me play with the red button. I love it.
Can I ask my question now?
Yes, sure.
Great. Okay. Yeah, I was actually wondering what the added value is of defining all these optical parameters without having a model for the optical feasibility calculation. I mean, I have made that comment many times before. I think this is still an unresolved issue, in my opinion.
Yeah. So yeah, I remember some of your comments, but I guess there is in the document explanation why, I mean, the scope of the document, what the kind of content, and I mean, parameters were somewhat discussed several times with ITUT.
I mean, I see that, well, there are references in the document referring to ITUT recommendations where these optical parameters are defined. That's not the issue. The issue is, well, how can you actually use these parameters? Because as long as there is no optical feasibility calculation model defined, well, how can you ensure that an optical path is feasible or not?
I guess.
Gabriele, Francisco. I think, Dieter, this document, let's say, allow us or allow who wants to use those parameters to exchange the parameter from the network to the controller. Of course, is not, I think is not the objective of this working group defining the algorithm and how to use those parameters. Maybe this algorithms are defined somewhere else or in some other organizations or consortium, but not here.
Or maybe
we just give it a media here, not a recommendation on how to calculate those parameters or how to verify those.
Yeah, this is Young. I agree with Gabriele. I'm sorry. Yes, I think, this one just add additional parameters for path computation, but the feasibility data may come from some other system. So we don't assume that, this document should provide that. So that's our...
Correct. And by the way, it's stated within the documents, this exactly in this way.
That's right.
That we provide the information, and then the algorithm per se is, let's say, is not our business.
Sorry, I think Dieter's comment means that actually in ITUT there's no impairment calculation model, and then even we have capability to exchange the impairment information from the control plane perspective, but it does not make sense because there's no foundation to how to use it. Right? Yeah, speak from the, not from the chair point of view. Yeah.
Julien Moric. I think that everyone of knowledge is acknowledged that this is not the full solution to the big picture, but it's chicken and egg thing. We need to start with something standardized to start the next move, and this is one of the first items. I don't think the document is claiming to solve the full problem,
Exactly.
but it remains useful and required.
Exactly. That is written also in the text of the document, one of section 102. And we can make example why you don't even need to define an algorithm that everyone has to apply. I guess it's sort of customized, can be customized for every, vendor or standard or whatever.
Additional
guess-
question, if I may.
You may.
Okay. Is the set of optical impairment parameters complete, or are there parameters missing that are needed in order to do optical feasibility calculation?
Is complete according to the scope of the document.
Okay.
You may take the, if you read up to section 3, there should be enough answer to your question. With the proper references and the, okay.
Yeah, I still have doubts, but yeah, I think this should be documented in the minutes. And that's fine. Okay, thank you.
Thank you, Dieter.
So shall we move next? Okay, this draft is still an individual draft, but I like to present with the other one because this provides the encoding to the information defined in the info model. So actually is in this case, we have only a draft refresh. There was some major update presented in IETF a while ago. And here we just update the draft. The draft takes some interest with the new modeling with new young draft coming in the working group. So a quick refresh on the content. So there is the optical parameter, how is encoded. We call it impairment vector, actually a list of optical parameters, and the extension to the impairment, we call it impairment matrix, actually is an extension of the connectivity matrix defined in another, in the RFC 7579. And here we provide an extension to the resource block information as well, with the previous information. So here, authors believe that is ready for a working group adoption. If there is interest in the working group in the fact this kind of information, for sure, working group adoption doesn't mean that the coding is, let's say, complete. We consider fairly stable. There are some few open points, but that's up to discussion for the working group.
I see Dieter on the line. I don't know if I forgot to push the red button or you wanted to speak again.
I just
Yeah, I think
have another
You
comment.
have forgotten to push the button. I don't want to speak again.
Let me kick you out. No, you can.
I have another comment regarding the previous one. You asked for the last call, but there is the chapter 5.4 in which there is an editor node that has to be completed.
Yeah.
How you can ask the last
That's-
call with the not completed section?
That's one of the cleanup, and I want to remove also the reference. There is still one reference to the encoding draft that, to me, has to be removed. That is a minor section, and there was only, let's say, some control plane consideration. Doesn't add, let's say, specific content to the stuff. I agree with this. I realize that has to be cleaned up.
Questions against this one? Your question, Sergio, was about
Was the previous draft,
on
yes.
the previous draft. Regarding this one, I would say
Dieter has a question here, or no?
I would say
No, so it's far from the mic. Okay. Okay. Thank you very much.
Thank you, Joe.
Hello. My name is Jonas Ahlberg, and I'm going to present two drafts about management and control of microwave and millimeter wave interfaces. And the first one is about the framework. The status is that the draft was adopted by Ccamp in December last year. And since then, we haven't really received any comments or feedback on the framework draft. But we submitted a new version of the framework draft in June with the purpose to take care of some comments that we received when the data model was adopted by the working group. And those comments were related to a wish to ensure that these activities are aligned in a good way with other similar activities within the industry, mainly within the ONF, I would say. So we made an update and included a clarification that the definition of the data nodes, the leaves in the model, should be based on established microwave equipment and radio link standards. And they can be seen as some kind of a data plane standard for microwave and millimeter wave technologies. Right now, there are no open topics that remains to be addressed, and the framework has been used in the definition of the young data model. And the design team, the microwave design team, considers the framework to be complete. And we think that it's ready for working group last call. The second draft is the actual young data model for microwave radio link. We have presented this a number of times, but I will repeat that it's a model for controlling and managing the radio link interfaces themselves, but also providing a good way to show or manage the connectivity to other interfaces, typically being available in microwave nodes. For example, Ethernet interfaces, but also other type of more, call it legacy interfaces, such as TDM. It, of course, follows the framework draft and supports the use cases and requirements defined in that draft. One key characteristic is that it augments RFC 7223, and thereby it has a structure which is aligned with how other interfaces in a microwave node is expected to be managed. It uses established microwave equipment and radio standards as a basis for the definition, and it also uses the draft Ahlberg and the ONF microwave information model as the basis for the scope to be addressed by this young data model. The status is that it was adopted by the working group in April this year. And as I mentioned, for the framework, we received a couple of comments related to ensuring the alignment with other initiatives with the industry. And as already mentioned, we decided to do that by including a clarification that it should be based on these established standards. And we believe if we revert to these and other initiatives within the industry also base their work on this type of standard, we can ensure a good alignment within the industry. We've also added a subsection explaining that some of the attributes in the augmented 7223 may not be applicable or relevant for the radio link model. We've done a couple of model changes. I have slides for that, so I will touch upon that later on. And we've also made some improvements in some of the descriptions of the data nodes. There are two new co-authors in this revision of the document, and that actually means that all major vendors within the microwave industry is now participating and supporting the work we are doing here, which is very good. I would also like to mention that we have started to validate this model in practice by participating at the IETF hackathon earlier this week. There are two applications, SDN applications were implemented, one related to energy efficiency and another one related to dynamic frequency control. And that was implemented on top of an open source ODL SDN controller, which had an implementation of this young data model for microwave. And we actually received the award for best overall. And if you're interested, you can see more of this at Bits and Bytes later today. One change that we have done is actually removed one data node, and that's the data node RX frequency config, which was used to determine if RX frequency should be based on or calculated from duplex distance. Instead, we have clarified in the description of the two data nodes that RX frequency will be calculated based on duplex distance if duplex distance is the only parameter provided in the configuration statement. Otherwise, it will be taken from the RX frequency value provided in the configuration statement. The other change we've done is that we've added a new identity for external commands in the protection area. We've added the identity for forced switch, which means that the traffic is switched to a protecting carrier and is forced to remain there even if the protection criteria indicates that it's okay to switch back again. And the working group, or sorry, the design team, considers the young data model work to be completed. We are currently working on a restructuring according to the NMDA architecture. We have a proposal which we have already received some feedback on, and we see that there is a possibility to make it independent of the changes that will take place in RFC 7223. And we will be able to publish such an update fairly soon. And we are asking for a working group last call on this young data model as well. Thank you.
So,
thank you.
First of all, congratulations on winning the best overall project at the hackathon earlier this week. To you and everyone in the team. Some comments. The first one coming from a discussion with Lou that couldn't come today because of overlapping sessions, which is to try to make another effort to see what can be generalized, in the sense that the microwave work is all microwave technology is as a variable bit rate by definition. There are other technologies in which we can have a variable bit rate, like, for example, elastic optical. So this could be an opportunity to try to make this work a little bit more general. This doesn't mean, I mean, it's too late to start with a brand new work, possibly in this, and then do technology-specific extensions here. But there are some minor changes that could help put the focus on this. One of these could be, for example, my personal opinion. In the framework, just add, I don't know, a few lines saying that these most of the considerations done in the document might also be applicable to other variable bit rate technologies. This is just, in my opinion, just a minor update to the framework. Nothing else is needed. On the other side, the update to the model could be a little bit more significant. I don't expect super major changes. I see two options. One could be to have a new document, which is which includes the generic part, and then leave the microwave specific extensions here, or within the same document just to split the model and say this part is can be generalized, can be applicable to other technology. This part is purely microwave.
Amy here from Huawei. I personally would prefer the second option. I think that would be more flexible to go forward.
I guess so.
Yes. Yeah. Okay.
Okay. That works for me. Okay. Thank you. Thank you. One question.
Just one comment. I mean, you mentioned here that there is. I saw that there is a reference to the ETSI document, right? Or
Yes.
Yes. So, if in the Young model there are some parameters, and that parameters are coming from that, can you add the reference there in the Young model itself? For example, if there's some parameter that is defined in there, that you could just in the model just add the reference. And if in some cases, if there are some values that have some restriction or can only have some values because they are defined or there is a range that is defined that way in ETSI, also if you can add that sort of restrictions to the document.
Mm.
Yes.
I can just mention that we started doing that based on this ETSI 302.2117. And I think there are 17 sections or 17 different versions or chapters or paragraphs or standard documents in that series. And it turned out, at least when I tried to resolve this, that there's a sort of a circular reference between all these 17. So it was very difficult to be very strict on exactly which document out of those 17 that and a specific parameter was defined. So that's why we ended up in say, okay, let's just refer to the set of documents, these 17. But we can look into that again.
Okay, at least if some of them come. So here in our case in IETF it happens the same. There are many cases where the same is happening in several RFCs, but then in the end you put to one RFC where is the consider it as the main source. So the same happens to us in optical with ITU, that sometimes it's hard to find in which document you define the N or the M or something like that. But in the end, you need to put some reference. Thank you.
Thanks.
Giovanni speaking. Just a quick comments related to the fact that you may generalize some parts. Something that I see that I've seen already somewhere else regarding the protection part. So where you always see, mono switch, for switch, and actually I don't know if you have control about priority, who wins against the two, likely false, but something maybe has to state.
Preferred protection carrier. Yeah.
This kind of part, maybe. I mean, just as a suggestion.
That button for Italy.
Okay, you're next.
Sorry, I didn't want to let people wait for me too long. Okay, thank you. I'm Italo Busi. I'm presenting for the Transport MBI design team the status update of what has been done from last IETF meeting. So what is the Transport design team, or the motivation for the design team is the fact that in the IETF we are developing multiple YAM models which that could be applied to the MBI of the Transport SDN controller, but we have got two questions we want to answer: is how these YAM models actually applies at the transport networks, and the second one is if there are any gaps in the current YAM model IETF is developing when used for transport network. To answer to these two questions, the design team is looking at what are the use cases that has to be addressed at the transport MBI, and we are analyzing in details how the IETF YAM models can be used to address these use cases. And the working method that we have is we have a design team mailing list, given the bigger number of people in the design team. And we hold almost weekly conference calls on Wednesday at 3 p.m. European time to discuss contribution and open issue. And we have a GitHub area where we stored all our minutes and documents and track open issues. As sort of the first deliverable is a use case description in the Internet Draft, which has been updated since the last IETF meeting. We have added some description of the protection scenarios for use case number 1 for the single domain, single layer scenario. And we are planning to complete this document by addressing in order of priority. First, we got feedback that people want to see more multi-domain as higher priority than multi-layer, so we will go with the use case number 3 next step. We will complete some of the services for use case number 1, and then we can go and look at the multi-layer and single domain and multi-layer, multi-domain use cases. This draft has been created by collecting input from different SDOs, and we try to describe the use cases that have to be supported by the Transport API without making any assumption about which Young model is going to be used. Instead, in the analysis draft, we started in one new draft that has been published before this IETF meeting, which is analyzing in details how the IETF Young models can be used to address the use case number 1. And we have provided an example of how an ODU wide topology can be exposed as a transport MBI, how a transit service, so an ODU transit, an ODU starting from 2CE can transit to a transport network. We have provided detailed JSON code examples, so we've wrote down in details all the JSON code, and we are also validating that the example that we are providing are fully compatible, compliant with the YAM model. So it's a formal validation that syntax is compliant with the YAM model definition. And the next steps is to reformat this example, because if you look at the draft, we just provide a pointer to the GitHub, since it doesn't fit, the code that we generated doesn't fit in the 72 characters, and we were too close to the submission deadline to fix this editorial issue. We need to align this example to the latest YAM models. The YAM models in the meanwhile has been updated, so we have to adapt the example to the new models. Then we need to complete use case number 1, add the protection scenarios example, and maybe we will start a new draft for the use case number 3 analysis. In addition to the Internet Draft deliverables, we have also other deliverables, which is a feedbacks that we have provided as an output of our discussions and analysis to different working groups. So the first point we got also commented last meeting to qualify what are the assumptions we are making on the TIS working group activity. So we are assuming that the TIS YAM model are applicable to the ACT and MPI interfaces are as defined in the Young applicability draft in TIS, and we made it very explicit, and it looks like that the assumption is good for our work. We are making an assumption that how the T-tunnel model can be used to set up T-tunnel segments, and as a result of this assumption, we have triggered some discussion in TIS, which is still ongoing. So there are different opinions among TIS people, but we are continuing with this assumption because we don't have any counter proposal at this moment. So we will align with the outcome of this discussion when it is completed. We made an assumption that when you have to configure the labels, in our example, we were considering time slots, but I think the issue is generic. On the interdomain links or on the access links, since this link, the two ends of these links are controlled by different PNCs, it's only the MDSC is the only entity that can allocate a label which is available on both sides. So the assumption is that the label is decided by the MDSC based on some information which is a label set information that the two PNCs provide to the MDSC. And because of this, we gave some feedbacks to the T-tunnel topology model, which have been updated to provide the label set information. And also, we have an open issue last time when we indicated an explicit object and a number interface. We have a clarification that the router ID and interface ID are actually the node ID and link TP ID in the T topology information. And that was a useful clarification for people that needs to use the model. last feedbacks, thanks to the fact that we are validating our JSON codes with the YAM models, we have also found during the validation process that there were some mistakes, syntax mistakes in the YAM models developed by TIS, and we provided this feedback to the authors which have fixed the models. And for the feedback to the Ccamp working group, we have dedicated slides at the end of the presentation. Okay, I will go a little bit fast. This is presenting the use case number 1. We have already presented similar slides in the IETF 98. So at this moment in time, we are focusing on this interface, the interface between the MDSC and the transport PMC. We will not cover what happens on the interface between MDSC and PMPSC because it's outside of our scope, and we will later cover maybe the CMI for transport services. So today we are here, and we are considering this type of topology for single layer, single domain as a node view topology. And so you can see the abstract topology, you will have an abstract node for every physical node, and we use the same naming to clarify, to make it easy to understand how the abstract node on the MPI maps to the physical node in the physical network elements. We assume that on the routers is not visible in the MPI, but we have shown here to make the example easier to understand. And we have found that there is some information in the topology model, the external domain container, that provides enough information that allows the MDSC to know that, for example, router 1 is attached to the transport network to the S31 LTP, and the router 3 is attached to the transport network through the S62 LTP, such that if the MDSC needs to create connectivity between router 1 and router 3, it has to request to the transport domain controller to set up an ODU tunnel segment starting from S31 and then into X62. And this is done, and the assumption is that the ingress and egress points of this tunnel will be indicated in the explicit route object. This is the assumption that we have today, which not everybody in TIS agree with, but this is what we are doing today. And we will fix when we have right instructions. This is an example. This some code from our example. Since we are doing some validation, we are putting real identifiers, and you will see also the addressing schemes. And to make it more easier to read, we have put a sort of convention to do the comment. And we will strip the comments will be stripped down from the code before the validation. So we have to follow some conventions on the way we put the comments. Since the tunnel is not terminated, the source and destination TP ID should not be provided, and we put that as a comment so the reader understands that it doesn't need to provide that. It's not something we have forgotten. We can indicate that the tunnel is bidirectional co-routed. We have enough information in the T-tunnel model. And we have also validated the information that is in the OTN augmentation for developed by Ccamp for configuring the time slots and to configure the switching capability at the edge of the domain. And for the explicit part, that's we can indicate the ingress interface on S3 node. We use the router ID is the node ID of S3, and we give an IP formatted address accordingly, and the S13 LTP. This part will change because the T topology tunnel model has changed the name of these two attributes to make it more easy to understand what they are compared to the topology model. So what is the current status about Ccamp? Okay, we were expecting some use case gap analysis. We were expecting some work on the missing YAM models and the guidelines. So we have published the use case addressing the first point, and we have started to publish the analysis for use case number 1, and we have given feedbacks to TIS about issues on the existing YAM modules. We have not yet identified new YAM models, but maybe in the next phase we will identify new YAM models to develop. Since it is already 6 months we are working, we have also made some considerations about what we have done well so far and what has to be improved. So what has been done well, in our opinion, is that we have been able to gather information from other SDO about their use cases. We have got input from ONF participants and from MEF participants about what they are considering, and we have taken all their use cases into account while developing our set of use cases. And we have this very good tool that helps us to develop the JSON code and to check that they are correct against the YAM code. And we think this is a very good idea because we are getting a very good quality examples, which can also be put onto some code and see running implementation. What we would like to improve, we would like to improve the getting feedbacks from other SDO, especially on the solutions. We have started to circulate the information about our work. We would like to get more information about what they think about what we are doing. And we would like also to speed up the work on the analysis ID, so more work to do. The hard work at the beginning is to have everybody on the same page to understand how to work, understand how to use the tools. That has been done. Now we have to just do the examples. We have the process on developing the examples has been started up, and now we should be a little bit faster. The next steps now, therefore, is to go to use case number 3, the multi-domain considerations. We got some feedbacks from people that they think that the discussion that ended up with the need to have the available the label sets at the edge interface is something generic, not only applicable to Young. So there is an idea that maybe we need to propose to PC to do some extension to PSUP to provide equivalent information. We are planning to do some discussion about applicability of transport API for the network slicing, since we think ACTN is applicable for network slicing. Transport API is therefore part of ACTN, and we don't know yet, and we will decide whether the current use cases are already sufficient to cover network slicing. We need to develop additional use cases. That's something to be discussed, and we would like to have to socialize what we are doing with the other SDO, in particular ONF and MEF. So that's complete the status update. Thank you.
I'm starting to understand why people complain that Italians speak too fast.
Flow control next time.
Please.
Hello, so I'm going to compensate by speaking really slowly, right? Are you in touch with OpenROADM?
Sorry?
If I ask if you're in touch with the OpenROADM course.
No, we don't have contact with OpenROADM. I don't know if, do you have any contact reference?
It's open.
Oh, okay, okay.
I don't have any reference. I'm just interested in this. Yeah.
Okay, we can look at that.
This is a good point. Well, actually, regarding the socialization of the draft, we could help you with liaisons and communications. This is something that we can do, however, once the drafts are working group documents.
Okay.
Because it's not that good to do it with individual contributions, even if it's more than individual. Another thing you said, you provided inputs to feedbacks to TIS. Under what shape you did that? I don't remember emails on the list.
We have sent some emails, and we have participated to the design team calls from T-Tunnel and T-Topology.
Okay, that's
Yep.
great.
Yep.
My fault.
It's very.
And I had another comment, but I forgot about it. You have one?
One minor comment. For the next step, I think also you need to talk to or have some coordination with the Eagles draft, because that draft also describes some use case for the, transport northbound interface.
Yes.
So to avoid if there are some conflicts, yeah.
Yeah, that's a good point. I agree.
I'm just referring to the previous question about OpenROADM. So our design team is dealing with the NVI aspect. So it is to be understood if OpenROADM, that in my view is a device model, is related to our work.
Yeah, it could be part of maybe the question we raised to them when we socialize the situation, that of course we are focusing on this interface.
Yeah. The comment is right. We are speaking about a network model versus a device model. Okay. So we could try to understand if there is a support for adopting the draft. So, first of all, how many people have read the draft? I'm speaking about the first one, the use cases, the list of the use cases. Almost everyone. Who is in favor of adopting it as a working group document? Almost the same number, which is almost everyone in the room. We will obviously take this to the list, but it seems the support is pretty good.
Okay.
Thank you.
Thank you.
Hi, Oscar González, Telefónica. So now we are going to go in another of these draft that is technology specific. In this case, is the flex grid, the young model for the flex grid optical network. So if you can move forward. So we are gonna speak about these two drafts that came from one. Okay. So why do we need this model? If we look at the topology itself, we have the T topology, which you know is generic. It is split it into the layer 3 topology. Also, we have the WSON model here, but we do not have yet a model to cover the details of the flex grid optical network. So we consider it is interesting also that you can request, you can modify, you can apply, work with flexi LSPs and with an optical network that is flex grid ready, which it differs a little bit for WSON. So here we propose a set of young models to be able to manage flex grid optical networks. All the concepts are based on the stable, well, no, it's already an RFC, the framework document that we did some years ago. So all the concepts are there. And basically what we aim at doing is be able to represent that in a topology, that when we export a topology, we are able to show the details of flex grid, we are able to show the details of the transponders, and we are able to establish LSPs that are flexi grid LSPs or SSON LSPs or whatever you call them. Okay, so can you move to the next one? Okay, so what is the? Thank you. That's a good idea. So what did we change from the previous version? So in the previous version, we had everything in a single document, but now we have split it into one is just devoted to the topology. So we have updated to keep it compatible with the latest stages of the T topology. Maybe here at this point we still need some discussions with you guys to see which is the best way to go from the generic model to the technology-specific model. I saw that Igor had some comments today for the OTN model, so I guess those very same comments would apply here in the way to do it. Another difference that from the previous draft is that there are some, let's say, non-standard parameters for the transponders that we remove. For example, we refer to sliceable transponders, so that is, let's say, by now, until that is defined in ITU or something like that, we take that out. And some minor changes, as for example, is the slot, the default slot with granularity that is added there. Okay, so the other version that we have is the extending the T-tunnel model, is the draft to define the flex grid media channels. So this one set augments the T-tunnel. And here there are some parameters or some new parameters, for example, the link channel that reduces the LSP. Here also some is worth mentioning also that here we include all the as in the channel, the intended configuration. So this is, you want some N&M for the FlexGrid LSP, and then you might get a different thing because maybe the granularity is different and so on. So we differentiate also between the state configuration and the applied configuration. Okay, so the models, both of them have been validated with all the tools. So they are working now, and so now, even though we think that there are still some work to do, and for example, here the case of the ports, that if to make it coherent with the traffic engineering models, we model as termination points also. So there are still some few things that might change, but we think that both drafts are ready to be adopted and can be a foundation to further work and further modification. I'm not saying that they are complete, but they are, I think, in a good shape enough to be taken by the working group. And I think the Flexi is completely in scope. We have the framework for the Flexi, so the WSON is stable now. It's progressing nicely, so maybe it's time to also dedicate some time to this one. Okay, so with this, if any further questions, comments?
Hello, Jan Kondrat from CISNET. Again, this is my first IDF ever, so I'm missing something very obvious. But as I was reading through this draft, there was there was a discussion about the M and N as in small multipliers, and as you said, it brings certain complications. For example, that the same numerical value of M and N could actually refer to incompatible channels. So my question is, was it ever considered to use just gigahertz or terahertz for both the center of a channel and for the channel width?
Yeah, what you want to clarify?
Gabriele speaking. There are at least two reasons because we choose N and M. Number one is this is the definition of ITUT. Number two, using with this kind of granularity, terahertz or lambda or nanometers, may end up we end up in rounding issues. So having 5 digits after the comma, after the dot, is not enough because the frequency may be interpreted in a different way. You probably saw the open road proposal. I was not agree with that proposal because this issue. So this is what we recommend.
Yeah, this is actually something that I can understand because we are actually designing some of our RWDMs using OEM modules. And yeah, I had quite a few implementation issues in some open source libraries when it comes to using decimal 64 because they implemented using double. So I know what you're talking about. At the same time, still, I think that it could solve the issue of maybe some confusion, especially for a newcomer like me, when it comes to M and N's meaning something else, depending on the granularity of for example, the device that you're using. But yeah, thanks for the answer.
Just a reminder, N and M are integer. So no way to make mistakes.
Yes, and let's say that N and M have the defined in ITU, and they are very clear. Other different things, as I said before, one thing is that you want a certain N and M, and because the devices might have a different granularity, you might get something wider. But I think that the concept is already in the framework, and also this is the effect. I think it is the effective channel. I can't remember exactly, but it was one of the slot width, and it is the effective slot width, which is what you really get. So here, also the beauty of the Young model is that you can say, okay, this is what I want, and this is what I get. But also the concepts are all, we take everything from ITU. So there, as we are not defining the data plane, so we are just have to deal with the restrictions that they deal. So, okay.
Yeah, we have Dieter in the queue.
Thank you. Yeah, I would like to echo what the previous speakers have just said. I concur with them that we should use the NMM values, and everything related to the NMM values is well specified in ITUT recommendation G694.1. And I would actually suggest that this recommendation should be added as normative reference to the two documents.
Good point.
Okay, put it in the minutes so we don't forget.
You do.
Not from here.
Please. There is a queue behind you.
So if I can maybe just explain how it felt to me when I read the ITU document. To me, it felt as if the M and N was used just something like an implementation detail or a vehicle to better convey the idea. But yeah, I understand it. Well, if everybody in this room understands it, maybe I'm wrong. So thank you.
Gabriele, can add another good point to use at least N. N is referred to the granularity, no? So in case of changing in future the granularity to, for example, 3.125, or if you want to have a fixed grid implementation like 50 gig grid, N is still valid. So in other words, this is very general, this one.
Okay. We will take the last question.
Thank you. At UG Tokyo, Fujitsu, and could you clarify discuss the terminology on this slide? The media channel or the network media channel or tunnel? Yeah, tunnel is maybe at we know that, but I would like to the question for clarification. Discuss the media terminology for media channel or the network media channel. Thank you.
Well, I think this terminology is discussed in the RefC. I can't remember in the framework in the framework document and in the ITU. But here is more about the media channel and network media channel were very, very similar, let's say. So this is why the question here maybe for the model is, do we need to have different constructs for media channel, network media channel? The tunnel might all be the same. So this is why we want to discuss a little bit this and just to clarify what really is needed in the model. Okay.
Yeah, okay. The point is simple that maybe this should be aligned with ITUT at 7D.872 OTN architecture, and now the ITUT has agreed to develop new recommendations called D.media and architecture for the media layer networking. So point is again please in align with ITUT recommendation in terms of terminology. Yeah.
Okay, so for the data plane, of course, we will align with the ITU, but there are also some things that are IETF specific and that the control plane constructs. So, for example, the tunnel itself is an artifact that you use to represent something. So this is what we need to align in IETF and take the data plane concept is that the one that we are thinking. And here we define how we abstract those data plane concepts here in IETF. Okay. But I think we have good discussions for the future.
Okay, thank you.
Yeah, I think just related to this question, actually, we debated among the co-authors. I think at least the namesake, maybe FlexGrid T tunnel model might be the right one. And then in detail inside, we can describe it. And I think this is a good base for working group adoption. Okay. Thank you.
There was one iteration on terminology alignment between the FlexiGrid literature and the ITUT corresponding specification in RFC 7698, the framework. And I think we may need to also aligning the terminology here with other IETF models. That's the next step we need to go.
Thank you.
Okay.
Dieter is a quick one.
Yes. Yeah, I would like to the authors to reconsider the redefinition of the connectivity matrix. I made this comment also during the TEAS MPLS PCE Ccamp session when Yang presented his draft. I think the authors should look at the TE topology connectivity matrix definition. And the other point I would like to make is they should also consider whether this is a read-only attribute as far as WDM networks are concerned. Thanks.
Yang, you have 30 seconds to reply.
Yeah, I think there are some late changes that, Ccamp people weren't aware of it. So I think we need to talk to Igor offline on those connectivity matrices. And I believe for FlexGrid, you have an application code on the interface. So I think we still need to have that element, which is additional element for this case. So it's not the same.
So in any case, we think we can take it offline with Igor and see how can we augment or modify or do whatever with the. But I think also that it is good to be aligned with the T topology connectivity matrix.
Okay.
Not just fully.
Thank you. Next.
This is Gabriele Galimberti, and I will present 5 drafts now, all related to, if you want, to FlexGrid. Let's start with the first one, that is actually extending the possibility to signal in using GPLS or label, other than the media channel and the media channel width, so the N and M. Also the possibility to allocate the subcarrier into this media channel in case of we have multiple subcarrier. So basically, GMPLS now is ready and I would say deploying to support WSON network. We got 2 very good drafts, very good RFC, sorry, that is 7698 is a framework, 99 setting the labels for flex spectrum, and the 7792, if I remember well, that define the RSVP. Those draft address properly the SSON issues, but do not give yet any possibility to identify what, how, and what is the position of the subcarrier that are inside the media channel. Of course, if you have a single subcarrier inside the media channel, the subcarrier central frequency is the same of media channel central frequency. But if you have more than one media channel, that is the case of, for example, flexible transponder, here we need to address this issue. As I said, the framework defines all the information and all the way to address SSON. Also define the possibility to have a set of multiple media channel or composite media channel. And the proposal is to, let's say, associate a media channel inside a composite media channel, so to identify the central frequency either of the media channel and a single carrier at this point containing this media channel. But with this solution, let's say, the carrier will go step at 6.25, while in some cases for Nyquist shaping, the carrier may be squeezed and may be allocated closer than 6.25 steps. Scope of this draft is to extend the label and propose actually two labels. One to identify the let's say request coming from the client on the UNI interface, telling to the network what kind of interface should be used, and also another label is to carry this information across the network and allow the control plane to share the information related to the interface and share the information related to the subcarrier position, also not only at the two ends, so at the transponder side, but also into the intermediate roadmap. Okay. The first draft was presented in Chicago. We modified a few typos and some description test, and also a TLD that was related to the label has been modified, removing information already present in the signaling defined by the 6699 recommendation, RFC. So here we have actually the network configuration. You can see at the two endpoints flexible transponders. Flexible transponder may have more than one carrier at this point. So the requirement here is to have, for example, a request to carry a 400 gig that are received by the transponder from a client interface, and then see how this 400 gig can be carried inside the SSON network. The transponder, of course, should signal, as is telling the network via UNI, let's say, available parameters like available bandwidth or available lambda, whatever, should also signal what kind of interfaces are available and other few parameters that are related to the let's say, to the signal or to the circuit that needs to be set up. The control plane, the GMPLS, take care of this information, make some calculation in terms of routing, but also in terms of spectrum allocation, and more in terms of carrier position inside the spectrum. Of course, the algorithms that are applied to make all these calculations are not scope of this document, so are, if you want, up to the GMPLS or SSON control plane implementation. As I said, in this example, we have, for example, 4 transceiver or 4 interface available. It's up to the control plane to make, for example, based on the routing, to choose all 4 interfaces and then carry, for example, the 400 gig payload using 4 carriers running at 100 gig, like QPSK modulation format allow. Or if, for example, the channel or the circuit is not too long, let's say less than 600, 700 kilometers, the control plane may decide also to use 2 carriers and then apply a more aggressive modulation format like 16 QAM and so on. The same is for the FEC. Okay, this is the first TLV we propose. As you see, the number of carriers are exposed from the client to the network. Also the client bandwidth, so the control plane knows how much payload has to carry. So in other words, knows how much payload can be shared on the different carriers. And then the subcarrier frequency tunability that is basically optional. Second TLV is, and this is happening in the signaling and inside the network, is the modulation ID, the FEC baud rate, and again, this is for carrier by carrier, the grid, the carrier identifier, in case of we have more than one carrier, this TLV will be, let's say, used for each carrier, so will be multiplied per carrier. And other, let's say, 3 parameters, that is J, is the granularity of the carrier position inside the spectrum, that can be 0.1 gigahertz as a default value, or even less, 0.01 gigahertz. So the granularity is very, very fine. K is a parameter that identifies the position of the carrier compared to the media channel central frequency. And then we'll see here the explanation. Here we have an example of media channel, which is N, so the central frequency is equal 4. The width is M equal 8. And then the value K1 and K2 identify the position of the subcarrier compared to the N value. That's all. Next step. I think this is something that may be helpful. There is already an implementation here. I think if you saw the last presentation in TIS from Pisa University, what we are talking about here may be helpful or can apply also that case. Of course, they presented a more general solution, but this I think can work.
Okay, we have Shilei and then Dieter.
Okay, thank you. Chile come from the T. Have just one question for clarification. So could you explain the relationship between subcarrier and OTSI?
So this actually OTS can be the definition of IETF of single carrier.
Yes.
You can have whatever you want here, actually.
It's because that's from my understanding, one OTSI may contain 2 subcarriers.
One OTS can be a subcarrier. Yes.
Can contain 2.
Can
That's
be
correct.
More also.
2 or more. That's correct.
Yeah.
Thank you.
Here to, let's say, keep the solution simple, I would say that each OTS is one subcarrier. Of course, in this case, the 2 OTS carry the same payload, or the payload is shared between the 2 OTS. No? So if I lose one OTS here, actually I lose all the payload. No, it's sort of inverse multiplexing done. But this is let me say, a detailed implementation. No, thanks. Dieter.
I have a question regarding the document status. I noticed that it has changed from experimental to informational. I know that we had some
Yes.
discussions at the last meeting, I would like to understand why this was changed. Secondly, I believe that this is still the attempt to get a proprietary solution standardized. And I don't know whether this is a task of the Ccamp working group to work on data plane standards.
I can answer for the informational. I think other than experimental, that is actually no more experimental, but is, I would say, product. We would like to inform what can be a solution to solve a real problem of, let's say, multi-carrier transponder.
I guess
A
Juliana
product,
wants to reply.
a product from which vendors? I'm
vendor.
talking plural. I'm talking plural, right?
I guess just a second. You want to reply to the second question. I wanted to spend a few words on the status of the draft. Why did you move from experimental to informational? For me, this is the perfect example of an experiment, because there is no yet no. It's something that is not standard, but there is code. So it's an experiment.
No problem to go back.
Okay, Julien.
Julien Meric, Orange. As an operator, I would be happy to have other proprietary proposal joining this initiative, because that would be the way to turn into a standard track document. Considering that I am actually deploying this kind of multi-vendor alien wavelengths, this is something that is actually required to stop doing just manual multiple step operations. So I definitely support that. And I'd be happy to see Jitter or someone else joining. Thanks.
Thank you. Of course, we are open to any comment.
How would you like to see it?
Anybody wants to contribute here.
How do you like to see this progressed? As an experiment, or don't say standard track, please?
Yeah, well, I think if there is a specific, very explicit data plane specification, it will be very helpful to have that kind of multi-vendor stuff that support subcarrier. But currently, we do not have this kind of specification, and if different vendor comes with their own implementation, I don't know. I don't think that will solve the operator's problem.
I can answer here. To me, okay, any vendor can come with its own solution. It's open, in my opinion, but from the vendor point of view, would be a mess.
Right, we have, but different with you. So,
yes,
no problem.
Why don't you propose your solution and see what is the best?
Giovanni,
Just-
speaking operator required this, by the way.
Just a second before we move on. You still have 4 drafts to present,
Yeah, I can
and
be very
you have approximately 10 minutes. Up to you how you wanted to use your time. Take the questions, go on.
In my
press the
opinion,
button.
as we are having a pretty good discussion here, I would prefer to invest the time here.
Your
We
call.
can skip. We can skip also the presentation later. So go ahead with the question.
Okay.
Yes. Perfect.
Okay, my comment is very simple, and I use again, and my comment is this draft includes the definition for the modulation ID inside, but I need to ask for the clear reference and what kind of the modulation ID. Or, yeah, maybe this is the out of scoping IETF, but at organizational work.
Yeah, actually, I listed a bunch of modulation format in the draft, no, and probably this is not an exhaustive list, and probably is not the best way to represent these parameters. No, let's say today we have just numbered each modulation format. I think this probably could be a weak point of this proposal. It says that we should extend the agreement. Okay, QPSK could be number one. I don't know, 68 QAM could be number two or whatever. This is absolutely open, and even if we have already an implementation, it's not an issue to change.
Yeah, Italo Busi from Huawei. I think there is some standardization working question 6 of study group 15 for the optical interfaces, and it will be much better if we wait and we develop a control plane for the standard data plane rather than for different or proprietary solution, because we don't have a standard data plane what we are controlling. That's my concern. Thank you.
I agree to wait, but the market is not waiting.
But no one prevents to go to go on with an experiment and then go for the standard solution.
No. You said before that is no more experimental, but it is a product. Question is that if IETF has to standardize company products, even if supported by operators.
But an experimental draft, that doesn't mean standardizer. It can't be informational because you are defining TLVs, and that can't be informational. Yeah. Let's progress with the assumption that the draft goes back to the experimental status.
Just one comment regarding multi-vendor. The issue that we are seeing also in the past, that there are for sure standard, for example, the ITUT doesn't define the interop standard, but for example, we were making 100 gig interface working, actually talking with ALU 100 gig interface, and we did the interop. I mean, Cisco and ALU speaking each other. So there is a need to, let's say, understand if the two interface, even from different vendors, has to talk, are able to talk to each other. So this kind of work is somewhat needed. I don't express my opinion right now about the path, but it's something we need to move, even if standard doesn't, let's say, will come later on. Then the other part regarding the modulation format and so on, we did in the past the optical interface class discussion. This is a way where you actually carry around, let's say, numbers, and you define the meaning of the number somewhere else. So we may define an external, let's say, registry table where you can refer, and yes, you don't need to, let's say, go through changing your encoding if you change the modulation format or whatever.
Yes, Giovanni, that's right.
Julien, just a piece of answer for Sergio. There are already many existing IETF documents that explain how a given implementation is doing this using experimental or informational documents. And here, if you ask me to choose between this informational or experimental things versus nothing, I choose that clearly.
Thanks.
Thank you.
I think if there is no more question, we can. Time slot is over. Thanks a lot.
Thank you. And now, beyond 100 giga. Which is number 11. Yes.
Okay, thank you. This is actually from the presentation I'm going to give about the GMPS routing and the secondary extension. Sorry, GMPS routing and the secondary framework on beyond the 100 gig. As you can see, there are so many guys interested on this topic. So next slide. Okay, let's first talk about the and phases of this draft. The draft mainly focuses on the control of beyond 100 gig specific capability using GMPS. Some bullets, some information just need to be noticed. That the first one is that the ODOC is just a layer network with full monitoring capability but no flexibility. It's because just as described in RTOT Z.872, there is no concept of ODOC subnetwork. Which means that the ODOC does not support time slot switching. And the second capability is about the ODOC, how to transport the ODOC signal that can be viewed as being formed by interleaving N ODOC signals, which are labeled 1, 2 until N. Each of them may be transported over different interfaces. The ODOC ISP should be able to bind these signals or these instances together and distribute them over different interfaces. Also, there's a special OTOC signal, which is the OTOC-M. This signal is have the same overhead as OTOC, but only M tributary slots of capacity. Also, the ODOC only supports the 5G, the time slot granularity. About the TPN, I think it's the same. The use of the TPN is the same as that in ODOK. So the GMPS control plan should be able to support for the TPN allocation and negotiation. One thing that I should remind is that we did discuss about the ODOC ISP. What is ODOC ISP? But it looks like we forgot to include this in the draft. Maybe after this meeting, we need to make some minor changes to the draft to address this. So next one. Okay, about the history of this topic. The first version of this topic was presented at last year November at a SEAL meeting. Current version is actually produced by merging of two drafts. And the next one. Also, just since last IETF Chicago meeting, we have discussed several different topics. The first one is whether FlexO is in the scope of this draft, and the answer is no. We added some description to a draft that to describe the transport of OTOCN. This document just views OTOCN even if there are some digital sublayers involved in the adaptation. This document just reviews this and other transport mechanism as lower layers. OTOCN is defined as a separate layer, and therefore FlexO and other transport mechanism are considered out of scope. Also, another topic that we discussed is about Flexi and 400 gig use cases. We just read some editor note about this, that all these cases actually map the non-OTN connected signals into audio flex signals of various rates. It might be better to combine them into one category that handles audio flex IRPs. So from a control plan point of view, the difference in the data plan processing are not relevant. So maybe we need to make some changes to a draft to place the use case in some categories. Okay. Okay. Oh. Okay. Okay. About networks, next steps. As mentioned before, this draft has been presented 3 times, so we request for working group reviews. Also, I think about the issue, about the topics we also have an agreement that this draft has included almost every capability that we need to cover. We need to use GMPS to control. So it does request for the working group adoption. So we can use this draft as a base for developing some solution-based document. Okay, thank you.
Thank you. Yujit from Fujitsu again. Could you back to the previous slide regarding to the use case for the Flexi and 400G? Does it mean the client for ODU Flex, right? And I have read the latest draft version 01, and for Flexi client, and there are two use cases. One is Flex Aware into the ODU Flex. Yeah, that is in 709. Yeah, I have no problem, but the other is one, section 4.5. And yeah, there's another example at the Flexi client into the ODU. But I cannot tell. This is it looks something new invented in this the draft version 01. So please check carefully. And this is really in line with the G.709 and Flexi IA in OIF. Thank you.
Okay, thank you. I needed to check that.
Thank you. Laura, your turn.
How are we doing on time? Are we late?
There is a lot of freedom.
Oh,
Maybe
okay.
time.
So,
So you have 15 minutes.
I have 15
And
minutes.
you have to decide how to share them with Mark.
Ah, okay, so I do what I can. First of all, IETF does thanks to the. This doesn't look the one. Okay, this one looked correct. The one I saw on the slide repository earlier didn't. Okay. So we have a draft that we call Flexi framework, signaling framework. It very often signaling for configuration. So actually both. The document is just now labeled as informational. I've heard that people want to make it experimental. Though I don't really understand what an experimental framework is. It's kind of odd. So if we go there, someone has to explain it to me. So look at what happened with this draft since last time. And last time was Chicago, and I wasn't in Chicago. So partly for me, it's like a little bit longer. We have added 2 new contributors, and the number of contributors are going up all the time. We restructured the document quite a bit. When I first read this document, it actually struck me that it was a Flexi tutorial. And I think we need a Flexi tutorial somewhere. We could probably write something for the IETF journal or something, but it's not what we want to have in the working group. So here we need a typical IETF framework document, and we cannot tweak it to become that a little bit more than it was before. So we put priority what is interest for IETF. And I also simplified use cases. I hope I have not oversimplified them. People need to review and give feedback on that. What remains to be done, we need to do a final cleanup on the requirements. Requirements are pretty good, but sometimes it's not requirement language. You can't. A requirement is something that you can measure if you reached or not. And sometimes here you haven't done, it's not possible to do that. And then we need to look at the document and see if we have something in this document that actually needs to go into other documents, like specifications that's coming along. There could be a bit of that. Where do I? How did you do it? No? Oh. Oh, did you do that? Okay, so here is how we propose to split up the documents. We do one framework, and that's the document we're talking about today. That's a normal framework, architecture, requirement, use case information goes into that document. I think we would kind of not stress use cases more than we do just now. And then we need signaling and routing documents. I see that we need extension to RSVPT. We need extensions to the IDPs. There is one document that Mac is going to talk about in just a few minutes. And then, since this is link technology, it needs, at least we need to ask the question that we need to touch a LMP. It could be the case that you must do that. And then, of course, where's Benoit? We need a Young model for Flexi also. This is work in progress. I've tried to come up with a reference model. It's kind of there, but I need comments, feedback, help to refine it. What it basically says is that we have 3 types of connections for Flexi. One is actually when you connect routers back to back, the bottom. One is when you connect it through an OTN network, but where the OTN network is not aware of the Flexi. And the last one is that you have an OTN aware, Flexi aware network, and at the top. We need to kind of put interfaces, reference points, and things into this picture, and I need help to do that. And if you have ideas, please contact me and send me text. So we're looking at Flexi data plane just quickly. So what we have is, see if I can do that. This is animated, and with this one, it's going to be. So we have nodes. Can I do a pointer? Is that the top one? No. That one. Ah. Okay. So we have nodes here, node in the middle, node at the end, and we have some type of connectivity in between them. So first of all, we call this. It's not that bad on my slide. It says Flexi link here, and we're pointing at the blue big pipe here. So what we have in Flexi is a pipe between 2 pair of nodes from here to there and from here to there. And then the next thing is that we have Flexi sublinks. They have the same reachability. So you have a Flexi sublink, it's red, by the way, not brown, between the 2 nodes. And then you have them there. And then what we get is a Flexi interface and a Flexi sub-interface. Do you want to jump in, Deborah?
Well, I was going to question the diagram. You have that middle component. What are you switching there?
So Flexi is not a switching technology.
Okay. So what is the middle?
We actually need to switch on an MPLS label. Can you wait one slide?
Okay.
Yeah. So this is why we have the what comes out of Flexi, the interfaces, sub-interfaces, links, and sublinks. So Ethernet and flexible Ethernet are a link technology. So here we getting into what you're talking about. We want to establish an LSP over Flexi, and there are certain things we can do. So in this example, I assume that the Flexi group is pre-established. It's not necessary. We could also potentially establish a Flexi group by GMPLS configuration, though there are problems. So if, for example, if you have 4 100 gig files between 2 nodes, do you want to establish 1, 2, or what size would those 2 be? Or would you want to establish 4 different flexi groups? And the choice you make is not readily available coming in from requesting a LSP over flexi. So next thing we have the it's not my friend. So you have the links, you have the sublinks, the green one, and then you have the flexi LSP end-to-end over the flexi network, and you're actually switching on a MPLS label. Now you can ask your question.
Okay, Deborah Brungard as an individual. I still don't understand when you say you're switching a flexi sublink using an MPLS label. Are you switching MPLS packets or?
Okay. Andy Malice, there are actually 2 different approaches that one can use with labels and flexi. One is the GMPLS approach. The other is the MPLS approach. The GMPLS approach is that a label does not exist on the data packets. Rather, a label signifies calendar entries on a particular flexi link. So you map the label to the calendar entries that the data is going to go into, just like time slots, right? So it's just like mapping to time slots in OTN. The other alternative is the MPLS approach, where you have actual MPLS labels on the data packets.
Actually, and you're going where I was going, but thank you. That was right. What I was going to say. The thing is that when you come to the green thing here, that one in this example, you establish that through GMPLS signaling and actually telling the shim and the switching equipment in nodes how to treat them and where to place the MPLS label.
Yes.
The MPLS label is requested from here all the way up here and then established back again. So, and you do both. You can also, if you want to, configure the flexi group. But as I said, there is a problem there that I can't get my head around that. Are there any?
Well, to continue, the diagram then is very misleading because it looks like you're switching a flexi sublink, and flexi sublinks are not switched. They're just link by link terminated.
Links are not switched. Never. No technology.
Well, that's what the flexi. If you sub client or however you want to refer to it, the calendar slot is not switched. It's not even mapped to OTN. It's terminated. Yeah. So the flexi part is just, yes, all links. So it'd be very helpful if you show, if you could show the actual LSP, for example, MPLS packets, IP packets, end to end through the routers, and then show clearly that your flexi link is just, including the calendar slots, is purely link to link. It's purely a link.
LSP, would that solve your problem?
Well, yeah.
Huh?
But so I guess we're not seeing. I'm not seeing why you need.
Picture is only one.
So I don't. It's just. It would be, I think, very helpful if you could show the architecture that is in the OIF implementation agreement, and it's also in the G.709, which is publicly available, right? The Amendment 1. It's purely, flexi is purely a link, and the calendar slots are terminated each side. Or on OTN, you have 3 mappings, but then you're switching an ODU flex or a GFP type container.
In this case, we don't do the ODU flex, we do the MPLS label.
So you're purely looking at connecting the routers with, but then your flexi is just an encoding of the link. That's all.
It's a way of establishing an efficient link that actually can guarantee you bandwidth.
Yeah, that's fine, but you're only discussing it as a link. It's nothing to be switched. So you only have your encoding for the link. You need to.
I think
anyway,
I
it would be
think we
very
need to take
helpful.
this discussion kind of back to the list,
It would
because
be very helpful if you actually draw this out in that we can see what you're actually trying to do.
okay, you have a long line behind you.
Usually again, maybe overlapped with Deborah's comment, and let me clarify. Is Flex-E sublink different from Flex-E client? Is the same one?
Flexi
Sublink, the green pipe on this figure is. This means Flex-E client defined in.
No, I think a Flexi sublink is a link with one Ethernet interface in each end and a Flexi client between them. Is that?
Maybe it looks like the Ethernet client was a client, but maybe this file introduces too many terminologies for in this draft, and to clarify on this point.
I understand that I need to clarify something here, and I need to actually figure out exactly what.
Maybe the point is that this draft is only focusing on the Flexi mode only terminated, or the unaware, or the partial aware.
There is a difference between the draft and the slides. This is kind of high level. So
yeah, it's previous slide one. So maybe this is talking about only terminated mode for the Flexi. In my understanding, it's correct. And please write it. And this focusing.
Okay, please help me writing it.
Okay.
Mac.
Yeah. About the question about whether it support Flexi switching. No, we do not support Flexi switching. We just you can consider this as a Flexi terminate at each hop. It will the Flexi frame will recover to packet or either a packet or empty packet, and then transmit to the next hop. It's just like I think it's just as defined in the current OIF Flexi one.
So you're saying it's a switching capability and not a GPID?
We just use the amperes to set up an RSP over FlexiLink.
Actually configure the infrastructure and set up the LSP. That's what we need to do. But we're not switching on the Flexi level.
Yeah, that's right.
So you're setting up an MPLS LSP where the encoding
so we're
is
setting up the MPLS LSP.
Yes.
Okay, so let's go for that. Then we are configuring the underlying sublink and link. And we do that by GMPLS signaling and routing.
So actually, I think you guys repeated that Flexi is a kind of link technology and cannot be switchable. But actually, look at this picture. I think this picture is a little bit, misleading. It sounds like to give people a kind of feeling that Flexi can be switchable. So, because based on the OFIA implementation,
so can you explain exactly why you get that feeling? Because I don't get that feeling looking at it.
It's Deborah again. I think what we hear is that you're trying to control that Flexi link, and it's not controllable. This is a hard adaptation function that is mapping just internally that MPLS packets, which become then Ethernet, actually, right? It has to be MPLS mapped into Ethernet PHYs because it's mapping the actual, coding into the calendar slots, and you have no control over any of that. That's a hard adaptation that is just automatic, so you can't control any of these flows. So I think, anyway, I would recommend, because it was a lot of discussion at the last ITU meeting, and you have a lot of ITU folks there that you get together and you can bang out what actually is needed.
Okay. Do we want to have a look at Mark's slides to see if
okay,
maybe?
So I have two requests, not for the slides, for the draft, to actually review and help us improve it, involve more people to develop this, and I think it's been around long enough to actually for the working group to take control of the draft about now in time, maybe one more version.
Okay, thank you, Lord. Mark,
Okay, Mark,
you have 1 minute. One.
Yeah, I just encourage people to read the draft, and we can discuss how to improve the draft. So I don't want to present the detail. We don't have enough time to present in detail. So just read the draft, and we can discuss even in the rest of the week. I can discuss by email.
Okay. Just one comment. Once we understand what we wanted to switch, what we wanted to advertise, and so on, I would say this is a Ccamp draft, not an ISIS draft.
Okay.
It's a technology-specific extension to ISIS.
Okay.
It's already late.
Generic. Well, I think I already commented that one in the ISCS meeting, your document. I agree with you. Usually we've been doing IGP extension within the Ccamp working group. So if it makes sense, it does belong here. I don't here just to do my comment again. I think the solution on the problem statement here don't match, because it's about using switching capability descriptor to do something which is not aimed at being switched. So clearly it's not ready.
Yes. So we need to make it clear what you want to advertise, because you made it clear that this is not something that you're going to switch, but I had a look at the draft, and you are speaking about changes to the switching capability descriptor.
Okay, yeah.
Okay. So thank you everyone for the hard session. We are done, and see you at IETF 100.
So where's Lucius? Okay.
Yeah. So what I hear people here say is that we can't